welcome to my channel. Now we are on the chapter 6 of the thermodynamics, which is the gas and power cycle. So we have a sample problem here. An air standard diesel cycle has a compression ratio of 20 and a heat transferred to the working fluid per cycle is 1800 kilojoules per kilogram. At the beginning of the compression process, the pressure is 0.1 megapascal and the temperature is 15 degrees Celsius. So determine the pressure and the temperature of this point of the cycle. And then number 2, the thermal efficiency. And number 3, the main effective pressure. So to solve this problem, first is we need to substitute our given. So first we need to solve our B1. So B1 is equals to 0.287 times 288.2 over 100. So we can find this value here in our property table, and which is equal to 0.827 cubic meter per kilogram. Next, to solve for our B2, we have the formula B1 is over 20 is equals to 0.827 cubic meter per kilogram over 20, which is our compression ratio. So it is equal to 0.04135 cubic meter per kilogram. Next is we have T2 over T1 is equals to B1 over B2 raised to K minus 1. So we substituting our given, we have 20 raised to 0.4 is equals to 3.3145. So our T2 here would be equal to 955.2 Kelvin. And to solve for our P2, we have the P2 over P1 is equals to B1 over B2 raised to K. So substituting our given, we have 20 raised to 1.4 is equals to 66.29. So we have the value of P2 here, which is 6.629 megapascal. And then we have the heat loss is equals to Q3 is equals to Cp times T3 minus T2, and it is equal to 1800 kilojoules per kilogram. So which is our heat transferred. And then T3 minus T2 is equals to 1800 kilojoules per kilogram over 1.004 is equals to 1793 Kelvin. So our T3 here would be equal to 2748 Kelvin. Next, to solve for our B3, we have B3 over B2 is equals to T3 over T2, and substituting our givens, we have 2748 for T3 over 955.2 for our T2, and it is equal to 2.8769 Kelvin. So our B3 here would equals to 0.11896 cubic meter per kilogram. And then to solve for our T4, we have the formula T3 over T4 is equals to B4 over B3 raised to K minus 1. And substituting our givens, we have 0.827 over 0.11896 raised to 0.4 is equals to 2.1719. So the value of our temperature for here would 1265 Kelvin. And to solve for heat loss, we have for Q1 is equal to CV times T1 minus T4, and it is equal to 0.717 times 288.2 minus 1265, and it is equal to negative 700.4 kilojoules per kilogram. And then next, to solve for our W net or work net is equals to 1800 minus 700.4, and it is equals, so our W net here would equal to 1099.6 kilojoules per kilogram. And then to solve for our thermal efficiency here, we have the formula W net over the heat transferred. Substituting our given, we have 1099.6 kilojoules per kilogram over 1800 kilojoules per kilogram. So cancel out our units here. So our thermal efficiency would equals to 61.1%. So our thermal efficiency here would 61.1%. So to solve next and lastly, to solve for the mean effective pressure, we have the formula work net over B1 minus B2, and then substituting our values here, we have 1099.6 kilojoules per kilogram over 0.827 minus 0.04135, and it is equal to 1400 kilopascal. That would be all.